the previous videos, we talked about the 9 WKs, which are the knowledge and attitude profile. The WKs are a part of the graduate attributes. We have 11 graduate attributes, which establish the characteristics and the attributes of graduates to have the ability to perform engineering practices in the global market. We also talk about the relationship between the WKs and the WA. WKs are the knowledge and attitude profile, while WA are the graduate attributes. It was mentioned that if you design your program to be in line with all the graduate attributes, you should have covered all the knowledge and attitude profile nicely. Now coming back to the graduate attributes, you will have to read between the lines of the graduate attributes to know the components as well as the expectations as required from an engineer graduates. You will see a common term here, complex engineering problem. You see these complex engineering problems in WA1, WA2, WA3, WA4, WA5, and WA6. This complex engineering problem establishes the unique characteristics of engineer graduate as compared to the other types of engineering programs. You only see complex engineering problems under the category of engineer graduates, but you don't see those in the graduate attributes given by the other programs. This differentiates engineers with the engineering technologists as well as engineering technicians. Now the next question it will be, how do we define complex engineering problems? The word complex here is not just simply an adjective showing that the qualities of engineer. There are clear definitions for the complexity in the engineering program. To make it simple, when you read the statements of the graduate attributes, whenever you encounter the terms of complex engineering problem, which you can find them in WA1 to WA6, you will need to refer to the complex engineering problems definitions as given in the slides here. These are the attributes of complex engineering problems, which needs to be incorporated within the engineering program in order to train and equip the students with the ability to identify and solve complex engineering problems. In the short form, we call it WP. Now, how do we define a problem to be complex? IEA give a clear definition on this. Quote, complex engineering problems have characteristics of WP1 and some or all of WP2 to WP7. There are 7 WP in total. We are talking about the combinations of at least 3 components. What is compulsory here? It will be WP1. Having the WP1 is not sufficient. You will need some or all of the following WPs. Now, when it comes to the term some here, that means at least 2. We will not use the word some to describe one single item. Bare minimum, it will be 2. Or you can have all of the following WPs. So from WP2 to WP7, there are a total of 6. WP1 is compulsory. you will need an additional of 2 to 6 WPs in order to have the problems to be considered as the complex problem, as highlighted here. With that, bare minimum, it will be 1 plus 2. The maximum, it will be 1 plus 6. You will need at least 3 components of complex engineering problem to be considered to have appropriate level of complexity. Now let us look into those attributes. WP1 is about the depth of knowledge required. You can read the statements here. Cannot be resolved without in-depth engineering knowledge. At the level of more than 1 of WK3, WK4, WK5, WK6 or WK8, which allows a fundamental based first principle analytical approach. This will be the compulsory part for the complex engineering problem. How do you interpret this? You can restructure the statement here. First, cannot be resolved without in-depth engineering knowledge. That means this kind of problem requires in-depth engineering knowledge in order to resolve it. Second part, at the level of more than 1 of WK3, 4, 5, 6 or 8. That means it will have at least 2 of this knowledge profile. WK3, 4, 5, 6 and 8 are all engineering. Bare minimum, it will be engineering fundamentals. It can also be specialist knowledge in engineering. It involves applications, engineering design and operations, engineering practice, and on top of that, you require research literature in order to keep update with the latest development of the technology. Next, the third component for WP1, it will be allowed a fundamental based first principles analysis approach. Now let us talk about how do you specifically apply this. First, there is a need of complex engineering problems under WA1. You know WA1, it will be most likely be your PO1. You will have courses specifically designed attending to PO1. When you have the course attending to PO1, that means you will have to design your course to fulfill the elements as stated in the WA1. And WA1 specifically mentioned about complex engineering problem. With that, you will have to design your teaching and learning as well as the assessment to incorporate complex engineering problems. There should be engineering problems, and this engineering problem cannot be simply any problem. You will have to make sure the relevant engineering problem will have the attribute of WP1 plus 2 to 6 more items of the following WP. Now, this engineering problem can be introduced in various manners as long as it is incorporated within the teaching and learning. Now, looking at your teaching and learning activities. There are lecture, tutorial, assignment, presentations, computer-based learning, project supervisions, research, and other student-centered learning. Based on the principles of the golden triangle, the teaching and learning activities, the outcome, and the assessment should all be in line. If the course outcome is to be mapped to PO1, you will need to make sure there are complex engineering problem solving at the teaching and learning activities, and there shall be assessment up to the levels of complex engineering problem solving. You can introduce them in the lecture, you can have them in the assignment, tutorial or presentations, and other student-centered learning. And when come to the assessment, you will need to make sure there will be complex engineering problems. It can be in your progress test. It can also be in your final exam questions. It can also be in your assignment or any other student-centered learning assessment. Now the next question is, how do you prove that you have the complex engineering problem solving? This brings to us a form for the complex engineering problems to justify that we have those really incorporated within the program. Specifically, within the course, having the course outcome attending to the relevant graduate attribute or program outcome, requiring the complex engineering problem. Now come to the justification part. You read between the lines here. You will see three components here. First is about in-depth engineering knowledge. Second is about more than one of these WKs. And then third, you will need to make sure everything comes from the fundamentals and the first principles. You can adopt this form for you to do the justifications. Whether the problem that you design can or cannot be resolved without in-depth engineering knowledge. If the problem can be resolved without in-depth engineering knowledge, it is regardless the followings. This is definitely not WP1. Second, you will need to check, simulate the process of problem solving undergone by the students. Whether the fundamental base and first principle analytical approach are involved. If it doesn't involve this is definitely not WP1. The second component here, it will have the relevant knowledge profile of more than one type. You will have to provide justifications to describe the relevant knowledge meeting those knowledge profile. Let's say now you talk about engineering fundamentals. Let's say now the engineering problem that you design require the knowledge of engineering mechanics. You provide justifications to prove that it constitutes of WK3. Now, having only one item here, it will be bare minimum. As the requirement here, it will be at least one. Now, if you have more items here, this also fulfill the relevant requirements in terms of the knowledge profile. Now, fulfilling this only, it doesn't constitute WP1. It will only be when you have in-depth engineering knowledge, as well as it involves the fundamental base first principle analytical approach, and it constitutes at least one of the following knowledge profile. Then you know that that will be WP1. And then coming back to the requirement for the complex engineering problem. WP1, it will be the bare minimum. You need at least two more others. In this case, you only have one WP1. you will know that the complex engineering problem is not there yet. In this case, you will have to elevate the engineering problems, incorporating the other elements of the engineering problems. Let's say now you want to go for WP3, which is related to the depth of analysis required. Having no obvious solutions, require abstract thinking and creativity, and probably originality of the analysis. Now you have only 2 WP now. This is still not complex engineering problem. You require another one. Let's say you search through the requirement. You want to go for WP5, where the relevant problems is not encompassed by the standards and code of practice. That means the problems has gone beyond the coverage of the standards and the code of practice. Now if you have the item here, provide justifications why the standards and the code of practice are not applicable here, to which extent it goes beyond those standards. Now you have 2 items, which is WP3 and WP5, plus 1 item, WP1. You will know that you meet the bare minimum requirements for the complex engineering problem. Let us talk about the other scenario. Now you do not fulfill the WP1, missing one of the essential component, but you have 3 other WP. Let's say you're talking about you are having WP3, WP4 and WP5. Since the definition make compulsory of WP1, having WP3, 4 and 5 does not give you complex engineering problem. You can have all WP2 to WP7. Let's say taking this as an example. And then you have WP2, and you provide justifications for wide-ranging issues. The requirement here should be at least 3. You provide justifications. Now you fulfill the 3 items here. You have WP2, P3, P4, P5, P6 and P7. You have all those, but still lacking WP1. It is still not complex engineering problem. This is how we are going to use the form to determine whether our teaching and learning activities, as well as the assessment, comprises the complex engineering problems. We still haven't looked into the content of the other WPs, which we will introduce them in the following videos. At least at this moment, you will need to know the concept. How do we define the complex engineering problems, which you require WP1 as the compulsory, and some or all of the following WP. This is the first thing that you need to grab. The second thing that you need to grab is that you will have to read between the lines. Look at the components that constituting the WP. You will have to make sure the relevant components are available, and you will need to provide good justifications to prove that the relevant engineering problems has sufficient level of complexity. This will be the second point that you need to grab. And the third point that you need to grab, it will be you will need to refer to the course outcome of a particular course. Look at the mapping. If the respective course outcome is mapped to the relevant graduate attributes, specifically WA1 to WA6, where in this statement it has been specifically mentioned there are complex engineering problems. With that, by hook or by crook, you will have to have your teaching and learning activity as well as the assessment to have sufficient levels of complex problem solving. There are still flexibility given to you. You can choose to have those within any type of teaching and learning activities which you feel appropriate, and you may also choose to incorporate the complex engineering problems in the assessment as appropriate. If all this is properly done, you should have no issue meeting the relevant graduate attributes.